Where did we stop? Okay, page 38, right? Correct. I have one chat coming in. Sure, can upload this Thursday recording into Drive, as in the yesterday class, right? Yesterday class is not uploaded yet. I will do it ASAP. Okay. So for your info, guys, I still have some kids that has no access to Thursday recording. Oh, means you're skipping my class, boy. Yeah, I keep mentioning, I keep dropping the class link, ask you guys to request, please. All right, guys, let's go. So right now, let's look at the factor affecting the movement of an amino acid. So the first one, the ion, blah, 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 the higher the voltage, the greater the speed that will move. Okay, and also temperature, increase in temperature, faster the speed. Okay, and the size, the smaller ion will always travel, smaller ion travel faster than a bigger one. And next, guys, is the charge. Okay, so remember the charge. So higher charge move faster. Remember that. Okay, higher charge will move faster. The last one is shape. Okay, ion with a bulky group will travel slower. Jordan 的是。Hey, Jordan, oh, you're here. Not coming physical. I thought you Valentine Day with Kit Ying. Alright, guys, what is meant by isoelectric point is the pH at which an amino acid forms a Zweiter ion. A bit sad way today, Valentine. Nowhere you got so many. Don't lie lah. You yeah. Okay, guys, page 39. Okay, you see, right, guys, if we change the pH of electrophoresis experiment with amino acid, for example, if you use a buffer solution, right, that has a lower pH than, okay, a lower pH than your isoelectric point. Okay, so guys, what is lower pH, right? Low pH means under acidic condition means you have a lot of H plus. Okay, so right now this has a lot of H plus in it. Okay, so guys, I'm gonna give you one amino acid that looks something like that. Okay, please draw it up. And tell also, oh my God, also online. Chantal dating dinner now where are you having your dinner? With your boyfriend now, right? That's why skip physical. Alright, guys, first. Okay, let's say this amino acid, if we put it under isoelectric point. Okay, so example, if I put it in pH 7, which means they are isoelectric. Just imagine, right? This is pH 7. Okay, so at pH 7, isoelectric point. Guys, what is isoelectric point again?
Okay, I do one is a do.
So isoelectric point is when a Zweiter ion is formed, right? So COO minus and the NH3 plus is formed. Clear. Huh? What happened to make it form? They will just ionize. So this H, right, will just come here. So again, isoelectric point is when you have a Zweiter ion. So guys, Zweiter ion always have a net charge of 0. Can see plus minus cancel each other out. That is the definition of a Zweiter ion. Okay, guys, now if I put it slightly lower than your iso, okay, maybe I put it in pH 5.5. Huh? ACOO, yeah, sorry. Okay, so guys, now this is slightly below my isoelectric point. So guys, if I put it slightly below our isoelectric point, right, which means the H plus, there's a lot of H plus, right, lower pH, which means you are supplying H plus. Guys, where the H plus will go? Wait, CO minus ma, H plus and minus attract, right? Just like your boyfriend and you, right? Although no boyfriend, but it's okay. Or no girlfriend, lol, A-level cannot take. Alright, CH. This will still remain as a NH3 plus, but this time it's gonna turn into what? COOH now. Understand? Okay, then top part still the same. Okay, so this is when it's slightly below pH. Sorry, slightly below your ISO. Guys, let's say if it's way below your ISO, maybe in pH 1, what happens? Means you have a lot of H, right? So which means your NH2 on top also dissociates, forming NH3 plus. Understand? Because this is a minus, and H plus will always attract to a negative, right? Then this is just a lone pair, so the charge density of a lone pair is not as high compared to a COO. Okay? All right, guys, next. All the NH2 group will have picked up a hydrogen bond, a hydrogen to form an NH3, right? Okay, that means your amino acid carry a positive charge. Clear? Sure. Yes, All right, guys, now I'm going to move on to part B. If you have higher pH than ISO. All right, guys, let's go. Higher pH than isoelectric point. Example, guys, what is higher pH? Which means it is under an alkaline condition, right? Guys, what is alkaline condition? A lot of what? A lot of what ions? Alkaline. Hydroxide minus. Okay, a lot of OH minus now, yeah? All right, guys, now, you see, right? If you use a higher pH than an ISO, right? Example, we have this amino acid, CH2COOH. Just kidding lah. Try harder lah. Kai Hao, where's your girlfriend? Kai Hao. Kai Hao got a girlfriend about Kai Hao. Go talk to Areta first, Kai Hao. Go talk to Areta. Areta is helping me, you know. Areta, oh my god. Kai Hao got boyfriend. Kai Hao got boyfriend. Ew. For the single guys, this is our Valentine's Day right now. Yeah. Okay, so guys, let's look at our aspartic acid. This is aspartic acid. Yeah. All right, guys, now, again, I want you guys to, okay, just imagine, I forgot the pH, let me check. What is the isoelectric point of aspartic acid? Let's be precise. Isoelectric point of aspartic acid. So should I forgot, I think it's 4 point something. GG 2.77. All right, guys, go. Isoelectric point. All right, guys, isoelectric how? Which means a Zweiter ion. Teacher no do Valentine. Teacher chemistry no Valentine. Teacher chemistry again. If I Valentine cancel, you guys will kill me, bro. No. All right, guys. Zweiter ion is gonna turn into what? COO minus NH3 plus, right? Okay, guys. Next. After that, kid, let's say, right, if I put it slightly higher, maybe I put it as pH 4, which is slightly higher than my ISO. How? Go. Oh, isoelectric point, it's a fixed value for each and every amino acid. So different amino acid have different isoelectric point. Okay. So isoelectric point is not fixed, yeah. Okay, so different amino acid has different isoelectric point. All right, so guys, at pH 4, what's gonna happen? Go, please tell me. So higher pH means you have a lot of OH minus, right? So guys, if I take OH minus here, which one will react with the OH minus? NH3, right? So one of the H will react, right? To form H2O. So the NH3 will return back to NH2. Well done. Understand? Clear? All right, guys, next. Let's say if I put it under very, very high pH, 9. How? All right, guys, what will be? So your CH2COO minus on top also deprotonated, right? So COO minus. So you have a net charge of -1. Understand? Oh, sorry, -2. My bad. Yeah, -2. Done? All right, guys, now, so all the COOH group present will exist as a COO minus, yeah. Okay, this means that your amino acid carry a negative charge. Done. Clear? Done? All right, guys, now let's move on. Okay, the effect of R group on Zweiter ion. Guys, again, what is R group? Yeah, R group is your electron donating LQ group, right? So if amino acid, highlight the word, if amino acid has a long LQ group in R, increases the tendency to ionize. Okay, or increases the tendency to deprotonize. Okay, guys, now let's look at the structure of a lysine, guys. Okay, so before that, let's look at point two. This is due to the fact of the presence of electron donating property of an LQ group. Increases the charge density of lone pair, make it easier to accept a H. Alright, guys, now let's look at a lysine. Alright, guys, now let's look at Zweiter ion formed by lysine. Again, highlight this. What do you call your CH2S? This is our electron donating group, right? Okay, which means, okay, it pushes the electron to your NH2, right? Correct. Which means the NH2 attached to the R group will protonize instead. All right, guys, which means when a Zweiter ion is formed, so at isoelectric, okay, this time, yeah, your alpha amino acid COO turn into a COO minus NH3 plus. Do you see that NH2 here remains the same? Done. Here, oh my god. Ashki, okay. Okay, guys, once done, let's go. Try this question now. You guys do first, yeah. Meanwhile, give me a second. Let me mark my attendance. Let's go, guys. Guys, try the question first, huh? Okay, guys, let's go. He's lazy, please go. Okay, guys, lysine at pH 7. They say isoelectric of lysine, right, is 9.47, yeah. So, guys, let's draw 9.47 first, guys. Okay, so at 9.47, which one will deprotonate? This will deprotonate. Hey, this will protonate, right? Okay, so this turn into an NH3 plus. And a COO minus, right? Is that right? Correct. Okay, so guys, you have to protonate this, yeah? Reason being, you have a long EDG here, guys. Do you see a long EDG? So a long EDG will always increase the chance of protonizing. Okay, because electron donating group, right? Okay, guys, next. Okay, a lot of, guys, under pH 7, what will be? pH 7 means you have a lot of what? H plus, right? Correct. So if you add a lot of H plus, where the H plus will go? O minus, right? So it turns into a COO H burden. So guys, if you put it under pH 12, which means a lot of OH minus, right? So what will happen to the OH minus? We'll take away the NH2, right? Can. Sure. What is the the long electron donating group? Oh, why is it at the side? Yeah, because by right it's written on the top, right? Is it? Is that your question or no? Huh? Kind of. You see, this carbon is here, you know, left hand side, right hand side. You have a hydrogen here, then a head. So basically, this fella is like standing this position. Hydrogen, COO, NH, and a head. Is that right? Oh, because it's not low enough, Adrian, because the pH is not low enough. Yeah, because it's still under neutral, so it's not low enough to protonate your other NH2. Okay, because pH 7, right, your amine will not react. Understand? So pH 7, your amine will not react. Okay, let's go. All right, guys, next. A small change in pH. okay, from isoelectric point. So guys, again, if the pH of a buffer is just a very small drop, right? Okay, so the Zweiter ion will not change. Wow, this is the crazy part. So again, highlight this word. If it's a very small drop or increase from your isoelectric point, Zweiter ion will not change. Cool. All right, guys, let's go, shall we? First, let's look at asparagine isoelectric point 4. Isoelectric point 5.4. Let's draw it. Guys, how to draw asparagine? Okay, so COOH. Correct. Okay, done. Oh, no, is given here. Ah, ha, 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 ha. Wait, the entire structure is given. All right, guys, how to draw isoelectric point? Go draw isoelectric point. Do it now. All right, guys. So at isoelectric point, you get a formation of a Zweiter ion, which is a COO minus with a H, with a NH3 plus, with a CH2, C double bond O, and H2 like that. Correct? Yes, huh? No, cannot. Because that is not electron donating group, what? This is a C double bond O. In that electron donating group is CH2, 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 CH2 like that. Those are your electron donating group. What is this? This is an amide, baby. You see that? All right, guys, pH 10, go. Guys, what do you mean by pH 10? pH 10 is when you have a lot of what? OH minus, right? Let's go. Oh. Okay, forgot. Okay, a lot of OH minus, what will be, guys? Tuesday. Oh my God, what can I eat, man? What can I eat, man? Okay, let me order my dinner now. I haven't eaten. So sad. Yes, guy, how? pH 10 is when you have a lot of OH minus, which means the H plus here will combine with OH minus, right? Which means this entire thingy will turn back into a NH2. Clear? Sure. Okay, guys, next, go. Correct. Only CH2 is the electron donating group. Pure chicken. All right, guys, next. pH 5. How? So, guys, do you see that pH 5 is a small change, right? So, if it's just a small change, your amino acid will stay the same. Okay, understand? Clear? All right, guys, pH 1, how? Guys, if you put it under pH 1, it's still the same. Why? Okay, although there's a lot of H plus, okay, the H plus will not go into this position. Can anyone tell me what's the reason? Why your H plus will not protonate your NH2 on top? Yeah. What is amide? Amide is acidic, alkaline, or neutral. Can see that? Yeah, she correct. Good. Okay, amide is neutral. Remember? So guys, amide is neutral, which means amide will not protonate. Sorry, yeah, amide will not protonate. Amide stay as an amide even under pH 1. Hard, right? This is a tricky part, guys. Oh yeah, forgot. That's it. Yes, they will protonate also. If it's an NH2 here, just an NH2, yes, it will turn into NH3 plus. But this is an amide, so which is why it never turned into NH3 plus. Okay, if this is if C-double-bond-O is not here, it's just a R, the NH2, yes, it will protonate. Clear? Sure. pH 5, no. pH 5 is a small change. Zweiter ion will not change. So Zweiter ion stay as a Zweiter ion. Clear? This is the tricky part, guys. Okay. My rule, if it's a small drop, guys, for your info, none of it is, this part is not in the syllabus. They expect you to know. This part is not in the syllabus. They expect you to know. Yeah, so the senior that set for 2022, right? Basically, I never teach them how to do. Yeah, I never taught them. I also never taught them this. Suddenly, it just came out. Die. Yeah, so now you guys have to be careful. Yeah. Okay, so a small change, the Zweiter ion will stay. Because it's very low, pH 1 is a strong acid pH. How your isoelectric point is 5.4. Yeah. So let's say if you drop to 1, that's a lot. Let's say if it's dropped to 3, okay, it will still turn into this. Understand? It's just that when it drop into plus minus 0.5, this will not change. Okay. So if it's more than 1, right, then this will definitely turn into a COOH already. Let's say be it 4.4 also is a COOH here. If it's not amide group, then this will change only when the plus minus is more, for example, if it's pH 1, then the top part will protonate. If it's not low enough, then it will not. So you refer here. So the pH, right, you see, from here, do you see the increase is just a little bit, maybe 1 point something. So do you see the top part stay? Then if you put it under very high pH, that turns into a CO minus. Clear? Yes, when high, when low enough, then you just look at the pH. It's not, if you look at 7 to 5.5, it is still under acidic region. So which is why, right? Okay, so this is slightly below only. If you minus, it's only, if it's not, okay, if it's not 1, if it's not highly acidic, if it's not 1 or not 2, right, then don't protonate your top part. But if it's 1, protonate everything. Okay. Oh, good. All right, guys, this chapter is over. We are done with chapter 30, which marks the last chapter of organic.